Okay. Hi everyone, welcome to another session of our weekly office hours. Ask me anything about big data by us at Big Data Boutique. We have today Anton, who is joining us to talk about Kafka and Kafka Streams and do a short comparison between Kafka Streams and other streaming platforms. Just to remind everyone, just after the session, it's about 15-20 minutes talk by Anton. We are going to hold an open Q&A, and that open Q&A is going to be open to you all. The Q&A will basically be using the chat that you see here in YouTube. You can send us questions live over there, or you can just ping us on YouTube, on Twitter, or via email. You have the details here. And by that, let's start. Anton, the floor is yours.
Hello, my name is Anton Rodriguez. I am a data engineer specialized in real-time platforms. I have been developing real-time services for a while. And today I'm going to speak about Kafka Streams. The idea is to compare Kafka Streams with other popular frameworks like Flink and Spark and to see the differences. But also to introduce Kafka Streams, which can be new for most of you. So let's start with the typical architecture we can find in any real-time service. Okay, so basically we have users using an application, and that application is storing or reading information from a database. Okay, so the first integration we can do here is that the same application writing events to Kafka to be used later for an analytical system, for reporting, or to be stored in other databases, replacing, for example, ETL, a batch ETL. Okay, this is a very typical, good approach with a lot of advantages. So we have the events of the user behavior or whatever information we require in Kafka, and we can start to use it. Another approach is to receive that information from the database with something called change data capture. Okay, the idea here is each time something happens, something changes in the database, an event is generated and stored in Kafka. This has a lot of advantages. When we are working with legacy applications, we are not easy to modify them, so they cannot publish them directly to Kafka, maybe because they are running in all versions of Java, or because we don't feel confident enough to modify them. We can use this change data capture to retrieve information from them without modifying the original application. It's also a very performant way to extract information because it doesn't increase the load in the database too much. Okay, so it may have sense in some particular cases. Once we have that information in Kafka, we can start to processing that information, and for that we typically use a real-time framework. Some possibilities are Flink and Spark, as we see here, which basically read from Kafka, store that information or processes in a database, or it can store it again in Kafka to be used directly from another application. Okay, so for example, if we have a reporting application like app2 here, it can read directly from Kafka or from the database the events processes by Flink or Spark, update dashboard for reporting for our business users. That's just an example, but it's a quite typical architecture. And here we see the first big difference. Flink, Spark, they run services, they run in their own clusters, but Kafka Streams is just a library. Okay, so we can just put library in our application, and our application is going to be able to process and to manage real-time events, okay, and to read and write to Kafka in a very easy way. If we scale our applications with more instances, we're also going to be able to scale our real-time processing capabilities. Okay, so this is for me probably the biggest difference between these both the difference between these platforms. Okay. Well, let's see some other differences. Okay, multi-language. All those frameworks support different programming languages and different platforms. Most typically, Flink is in Java, but you can use any other programming language based in the GBN, like Scala. Spark, it's also based in the GBM, but it has really good support for Python too. Kafka Streams, it's mainly Java. There are support for Scala and some ports to other platforms and languages, but are not so popular as the Java version. Okay. As I told you before, the other big difference we have, it's in Flink and in Spark, we run our data pipelines in a cluster, but with Kafka Streams, it's just a library. Okay, we put that library in our application, and we already have the possibility to process events in real time, which is really nice. For example, if you have a microservice architecture and you would like to give them the possibility to process events, for example, to implement state storage and event sourcing. With Kafka Streams is really easy because you don't need to add any new component. Let's imagine you are deploying your microservices in Kubernetes. Well, with Spark, with Flink, it's possible also, but you need to deploy the new component, and it's a bit challenging. With Kafka Streams, it's just you use the same applications you already deployed in Kubernetes, and you can do it. The other side of the coin with Kafka Streams is because you don't have that type of infrastructure. Operate them are typically a bit more complex. If you have performance problems, if you need tracing, if you want to reboot something, it's not so easy. Okay, because it's just a library. You can deploy it in many ways. And in general terms, it requires more knowledge and more experience. It's a bit more challenging to operate Kafka Streams than to the operation you have to do with Flink or Spark. Okay. As everything, the advantages in technology usually mean disadvantages in different use cases. Micro batching, this is particularly for Spark. Spark is an extremely popular framework for batch pipelines. It was created for that, and because of that, the way to implement real-time processing capabilities is basically to do very small batches. So it's not real time processing. For 95% of the applications, it doesn't really matter because it's more than enough. But if you have particular requirements in terms of latency, then Flink of Kafka Streams, which have been designed and created specifically for that, have best performance. So again, this is not about what is better. It's just depending of your use case, you may choose one or another one. If you need to have a latency of milliseconds, probably Flink or Kafka Streams are better than Spark. Okay. The other thing we have it's how to recover from errors. Okay, in the case of Flink and Spark, they use checkpoints, and that means periodically they save the information they are processing, like intermediate stage. So if they have to start a game to process an event or to process information, they start from that particular checkpoint, okay, in the time. Kafka Streams doesn't support checkpoints. Okay, basically it relies totally in Kafka and in the Kafka capabilities to reprocess information. In a lot of cases that's perfectly fine and you have exactly the same functionality you have with checkpoints, but there are particular things which can be challenging, especially when you are restarting your applications and you need to resynchronize with Kafka and start to get again to read information from the very beginning. It provides some workarounds to manage those situations, but they are not in general so strong as the checkpoint capabilities we have in Flink and Spark. This is related to the infrastructure because Flink and Spark can use their clusters to store the checkpoints. It's quite easy to have that feature, but in the case of Kafka Streams, because you don't have that requirement, the only way to store information is in Kafka. And Kafka is really powerful to read informations while it's arriving, but if you want to read information from the very beginning, it's not so performant. Okay. Well, state. Basically, this is for a processing platform, the ability to process events not only based in the event you are receiving, but in previous events. So you save part of the information or an aggregation of that information to process the event you are receiving right now. Okay, this is a really powerful feature which allows you to implement different patterns in Kafka and to do things like event sourcing, CQRS pattern, and things like that. Okay, it's really nice. In the case of Flink and Kafka Streams, the support is really good. I would say the support in Flink it's even better than in Kafka Streams. Probably they are the major innovators in this particular space. In the case of Spark, it's perfectly possible, but I think it's not so good as it is with Flink or Kafka Streams. The reason behind that is because this is a particular feature for real-time processing, and I will say Flink and Kafka Streams are really more oriented to that than Kafka, so Kafka is a bit behind them in this particular case, but in the future I am sure it's going to catch up with the others. Well, batch mode. In some cases, it's interesting to use the same framework you are using for real time for batching. So you can reuse components and avoid some complexity. For sure, Spark is the winner here because it's indeed a batch framework. Flink has some support to this. I wouldn't say it's very popular because probably for batch it's just better go with Spark, but it's a possibility you can do. Kafka Streams doesn't have, as far as I know, anything related to this. It's not just a very interesting case usually, and they are not going to invest particularly on this because it's not really the best tool to do it. SQL, and well, as I told you initially, this frameworks require you to write mainly Java code. Anyway, I would say it's the most popular programming language in these platforms. Maybe not in Spark, where Scala's a bit better. But all of them provide you with the capability to write SQL queries to process the information in real time. So that allows teams which no knowledge of programming of the particular framework to do some integrations and so on. My experience with this is it's extremely powerful, but it's also quite complex to maintain it, because in the end the users have the possibility to launch very complex queries and to do things which can be not very performant, and that it's a nightmare from an operational point of view. Okay, so being really nice feature, usually in big architectures recommend to go with just a lower level API like Kafka Streams or Flink Java APIs. Well, integration with other systems, it's basically the capability to read not only from Kafka, but from other databases, from GMS, from MQ, and so on and so forth. In this particular case, Kafka Streams is not able to read from anything except Kafka, but there is another component called Kafka Connect, which basically it's oriented to read from databases and so on, and to publish the information in Kafka. So then you can process that information with Kafka Streams. It's not a very mature framework yet, Kafka Connect, but it's perfectly usable, and it is evolving very fast. Spark, it's really good on this. It has a lot of connectors and a huge community. For me, it's the better when we are speaking about integrations with other systems. And Flink, it's probably the worst in the sense of the connectors are quite limited. Okay, but you can use Spark or Kafka Connect to put information in Kafka, and then use Flink to process it, and that's a perfectly possible option. With real-time processing, you probably also want to do some integration with machine learning models or with graphs databases and so on. I would say in this case, Spark is the clear winner. The support of Spark for machine learning is really good because it's a tool very used in data science, so it's a clear winner. It's perfectly possible for Flink and Kafka Streams also, but you will need to do some coding on your side, some integration, and so on and so forth. Okay, the support in general is not so good as you may have in Spark, but it's perfectly possible. That's all. As you see, we have covered here some of the difference between those processing frameworks, and some of the things you can take a look if you are thinking use any of them. As you see, there is no clear winner or a clear framework for this. All of them are really good, but depending of what you want to do, it may have sense one or another one. And that's all. Thank you. If you have any question, just please let me know.
Cool. Thank you, Anton. I like the Kafka t-shirt you had there. Let's move to the Q&A session then. Anton, in terms of deployments on Kubernetes, what framework has better support?
Well, I'm going to start with the framework-based word support because it's quite clear. In this case, it's Spark Stuttering Streaming. Spark is quite complicated to deploy in Kubernetes. There is an operator from Google with the support of Liven, so it's possible, but it's not very mature. It's in alpha or beta state. It works quite well with simple pipelines, but if you need to do something complex, there are some limitations. So that's pretty clear. Regarding Flink and Kafka Streams, Flink has quite good support. It has an operator quite mature and stable. I never had the opportunity to use it, but I know other guys are doing it, and I think it's a safe bet. and Kafka Streams is really nice because it's just a library, so you can just put it in your Spring Boot application or whatever framework you're using, package it, and deploy it to Kubernetes. It's just going to work. Okay, there are some things you need to be aware of, like the storage needed for Kafka Streams, but that's perfectly possible in Kubernetes, so it shouldn't be a big issue. So both of them, Flink and Kafka Streams, are really good to be deployed in Kubernetes. Depending of your use case, one can be better than another one.
Cool, thank you. You also mentioned change data capture. I guess that also refers to MySQL binlog and those kind of things.
Yeah, that's exactly that. It's not only for MySQL. There are other databases which support it, like Postgre, Oracle, DB2, Mongo. So it's a really good way to read information directly from the database in real time because it's just very performant. We are not going to affect too much the database. We are just reading directly from the log, and then we can put all that information, all that updates of the database, of specific tables in Kafka, and then use that information to process it. There are many use cases, but I think two of them are the most important. One is when we have applications which are not able to publish directly to Kafka because they are legacy applications, for example. What we can do is just use this change data capture with some of the products available in the database market or some open source alternatives like the Debezium to read that information directly from the database and then process it in Kafka. So that's perfectly possible. It's a really good case. The other use case I have been doing it's for ETLs. So basically, we want to move information from databases to a data warehouse or a data lake. Instead of doing the typical batch process periodically, what we do is to configure change data capture, so we're not going to affect the database, and we are going to have a real-time string of changes in the database to update the sync. Okay, so to update our data warehouse or our data lake, and so on. So we can just move very easily information in real time. It's just a lot more stable and a lot more efficient than the typical batch approach. So I think that's the two more important use cases for Change Data Lake. It's something quite new yet, but there are a lot of engineers pushing in the last couple of years on that. And I'm sure most of the digital transformations we are seeing are going to involve to use the change data capture to implement real-time ETLs at some point.
Okay, so there's actually a really good question that's just come in. So Kafka is some sort of, it's a commit log, but many people use it as some sort of PubSub and queue system, and all of those real-time frameworks that you just described and went through, are they really needed to evolve our data architectures? So we all know there's been a lot of work on that area. So, MapReduce in the Hadoop days, and then Spark, and then all of those batch processing technologies. So we know how to do batch. We've been doing batch for a very long time. We can also do batch from Kafka, right? We can just read everything and do this in batch. And now we talk today about Kafka Streams. So it's processing something on the fly. So if we've been doing batch and we know how to do batch, and a lot of times it actually seems easier because you don't have to worry about how many times a message has been processed and things like that. So do we really need those kind of real-time frameworks and Kafka Streams and even maybe Kafka to work with that? Can't we just stick to using batch?
Yeah, that's a good question, a really good point. Well, I don't think batch is going to be anywhere. There are a lot of use cases which batch are perfectly fine, but I'm very used to work with in big corporations. Typically, all the batch architecture, it's a mess, and there are good reasons for that, because the business users usually they ask for to have information sooner. Now they want to have close to real-time information. So we are in many cases pushing the batch capabilities too much. Okay, and it's very typical. Something I usually see in many data architectures is having batch processes depending of other batch processes. Information which is copied to the data warehouse, and then it's copied to the data lake or to other system for reporting and so on. And what we are basically doing here is to adding dependencies between the data. If something fails, everything fails after that. And finally, our users have to wait for a report or for any information to arrive. Okay, this is a very typical problem right now in big organizations. With real-time data, you don't have that type of problems. Okay, you just are going to have the data in Kafka. It's going to be available for all the systems. From Kafka in real time, you can move it to the data lake. You can directly move it to the data warehouse. You can just reporting applications like Power BI or Tableau or whatever can read directly from Kafka and expose that information in real time. So you are just eliminating dependencies and making it a lot more simpler your architecture. And that's really good to be able to scale and to be able to implement some new cases from the business perspective. So for me, batch it's just still valid. But a batch alone is the problem. There is a really good talk, which is the name. The title is "The Future of Data Engineering," which proposes a maturity model, and it shows very well exactly that. Like the first step is to have batch, but in some point you need to have real time to oversee the limitations of batch. Okay, so for me, it's something which is going to collaborate. It's going together. It's not batch or real time, but if your organization in some point is going to need real time, well, maybe because your users have real time use cases, but also from an IT perspective, you are going to need it to evolve your data architecture to be more agile and to be easier to maintain.
Cool. That makes sense actually. But if you do use streaming platforms like Kafka and all of those that we mentioned, so Kafka Streams and compute data as it comes in, how do you keep how do you keep this state? So I guess you should somehow keep the state somewhere. So if the process crashes during operation, and if something happens, so you don't have to start from scratch if that's like big time processing on a continuous processing. So what actually happens if the nodes are crashing, if your processes are going away, and how do you actually maintain state in that case?
Yeah, well, that's the typical of one of the main problems people have when they start with Kafka Streams on Flink. Okay, well, we have here two different things. The first one is Kafka itself. Kafka is really nice compared with MQ in the sense of you put information in Kafka and you can, if there are problems, you can go later and replay that information. You can process it again and so on. So if you have information in Kafka and the applications consuming for Kafka have problems, it's not an issue. You are just going to store that information in Kafka for a period of time. When those applications are ready, they go into Kafka and they continue processing. And that's something which helps a lot in terms of reliability. Okay. The other thing is when we process information, when we are processing information in real time, in many cases, we need to take a look to the past and take decisions on to process information based in previous events. Okay, so we need to have this type of, or to store that type of state. Okay. To save that information, Kafka is not really good because Kafka is not a database in the end. If we want to go to Kafka and to search for a specific event or for a specific message, it's not really good. Basically, in Kafka, what we can do is give me the last information since the last time I connected, or give me the information from the very beginning, but I cannot ask Kafka to give me information in a specific point of time or specific information by ID, for example. For that type of things, Flink and Kafka Streams, what they do is they embed a database, which is a RocksDB database. It's an open source database by Facebook. It's an in-memory database. So basically what they do is all that information they need from the previous events, they store that information in RocksDB. It's extremely, it goes with the framework. And you can use that information in your pipelines. Okay, if there are problems and you need to recover that information, for example, in the case of Kafka Streams, what Kafka Streams does is, if you are rebooting the application, it goes to the local storage, trying to recover that information. And if it's not in the local storage because you are just running the application in a different pod or in a different virtual machine, it goes to Kafka to recover it. Okay, so it's perfectly possible you're not going to lose that information, but it doesn't help in terms of recovery because it takes some time depending on how big is your application. This is a very powerful feature, being able to process real-time events based in the previous events, but obviously has a complexity in terms of operation. Okay, the good things is Kafka Science, Flink, not so much Spark, but also Spark, are evolving a lot to support this and to solve the technical problems we may have. So I don't recommend to start with a stateful pipeline because it's a lot more complex than a stateless pipeline. But once you are used to work with Kafka and Flink or Kafka Streams, it's something really powerful you can take a look at.
Okay, that makes sense again. So I think you started talking about that. What are the limitations for an organization when wanting to adopt Kafka in general? So for general use cases or for Kafka Stream use cases, you mentioned operations. Are there any other challenges or maybe even limitations? And how do you usually work with those organizations to overcome them?
Well, for me, there are three different difficulties. The first one is the operation. Operate Kafka is not easy. It's a quite low level component. And there are a lot of things you can tweak and configure, and it's important to tweak and configure them, because if you are just using the default, you are going to have problems. So that's the first thing. It's you really have to have a good operations team, be aware of what is Kafka, how it works internally, have really good monitoring, that type of have everything automated. Okay, that type of things. So you really need to have a solid DevOps or practices in your organization to make Kafka work in a good way, okay, and don't face problems. The other two things are training from the people using Kafka to read from or to write to. Okay, write or read from Kafka is also not so easy. There are other things you need to configure to be aware of, especially if you want to have performance doing it. If you want to have a good latency, for example, there are some things you can tweak. Most of the things, or many things I worked with in the past, when they start working with Kafka, they think Kafka is like a MQ. They used to work ActiveMQ or RabbitMQ, and they think Kafka is exactly the same, and it isn't. It's just a totally different animal. Okay, it's really good in some things. MQs is not so good, and it's really bad in things MQ are really good. Okay, so you cannot use Kafka as you typically use MQ, and that's one of the big fails I usually see in organizations. You really need those things to have some support and to teach them what are the differences and what they have to do. Okay, I think that's a very important thing. And the last challenge I think it's the governance of Kafka. Okay, if you don't have a very good guidelines on how to use Kafka in your organization and just let Kafka open, teams are going to start to create topics, to read, to write to Kafka, and then when you want to do a capacity planning, it's going to be a nightmare. Okay, you really need from the very beginning to do all that work to make sure the topics are created following a nomenclature, the schemas are used properly, you are having quotas for your consumers and producers, all that type of stuff. So you make sure Kafka is going to scale in the long term, because technically it's able to scale very, very, very in a very good way. But if you don't do a proper governance of it, it's not going to be so easy. So for me, those are the three legs I really focus when I work in a Kafka project. And the things where what I see most organizations failing when they start to work with Kafka.
Yeah, that makes sense. We've been experiencing the same with customers that we're working with. Kafka, we often actually recommend not to use Kafka if you need some sort of a queue system. But Kafka is a big word, and everybody wants to take a part in it. But in the end of the day, if you need a queue system, and a queue system can answer your requirements, so RabbitMQ is just as good. If you do need to replay events and do a lot more complicated things, or you have a crazy throughput, then Kafka may be worth the overhead, and that I agree. So I see we're kind of out of questions from people. So Anton, thank you very much. It was really educating. And hopefully we'll have you again soon on more topics, not only Kafka.
Okay, that would be fantastic. Thank you for the invitation.
Yeah, sure. Bye-bye, everyone.
My